All right, everybody ready for class 2 of a 15-class series modeled after the school class that I teach at a local community college, Stratocaster Build. And I say class 2 for a reason. I'm used to school it being 15 weeks long. And so you might catch me saying week 2, week 3. It's not weeks on this video series, only because I may have time to do 2 in a week, or it may be a couple weeks before I have time to do another video. So I'm saying 15 classes or 15 episodes or maybe even 15 parts. I consider that all synonymous. But since this is a class that I'm teaching that models the in-person class that I teach at a local community college, there's certain assumptions that I'm making. Number one, the assumption is you have some basic woodworking skills. Okay, everyone that comes to my in-person class has already been through Woodworking 101 at the community college, and therefore they have already demonstrated proficiency in basic hand tools and basic power tools, and therefore I do not have to teach those kind of things. I'm also making an assumption that you do have access to a decent level of workshop tools. Now, I know everyone's going to be different in the power tools they have, the sizes and the capability, the capacities of those tools, and I'm going to try to be sensitive to that fact and give you alternatives whenever I can. Now, this is a building block approach to guitar building, and I say that because if you're jumping in here in part 2, episode 2, class 2 of the Strat guitar build, you really need to go back to part 1. In fact, why don't I back that up? Go back to part 0, which was my introduction to this series. So if you were on the other episodes, you know that I'm offering up different documents that might help you organize it. Here's a task by episode, a plans sheet where you can actually go through, and it's a guideline to construction with a place to take notes, and also a parts list for a Fender Strat. Those 3 documents is what I'm offering, but I'm not posting them online, so you have to email me at info@maximumguitarworks.com. A lot of people have already requested these, and if you're a little reluctant, maybe some of you who have gotten the documents, just post on there what you think of the documents. And to reiterate last episode, if you have emailed me and you haven't received those documents, then something probably got hung up in my server, which I'm trying to fix, and I think it might be fixed now. And so just email me again at info@maximumguitarworks.com and just re-energize it. Normally, I have those sent to you within 24 hours. So in preparation for starting to work on the neck, we do need some templates. In the last episode, we did talk about making templates and also talked about the templates that I can provide for those who want to purchase them. And for those of you that already have purchased my templates, thank you. A great way to support what I'm doing here is to purchase my templates or my guitar knobs or whatever else I may have to offer in the future. And since I had that rant a couple episodes ago, I will let you know the videos that are on the tube are also simulcasting on another platform that rhymes with stumble or fumble or something like that, just to see how it goes. There won't be advertisements on the other one, so there's a plus. The only template that we are going to use today is actually the neck. This is the Stratocaster neck template. Now, this is the version that's got my headstock design. The ones that I sell do have the standard Stratocaster headstock on it. And also, I do custom headstocks for those of you that maybe just want to use these in conjunction with your custom guitar business and you want to use your own custom headstock on them. So just let me know if you need that too. All right, so this is the only one we're going to use. But the first step is really to prepare the neck blank. Now, very specifically, we need to get this neck blank flat on both sides, okay? Flat on one side, parallel on the other side, to a thickness approximately 3/4 of an inch, and I'll talk about that more in a future, and to a length at least that of the template. I generally make them a little oversized, about 28 inches. It's 28 to 30 inches is almost a standard if you were to buy a neck blank. And then I also make mine 4 inches wide. Now, a lot of neck blanks come 3 inches wide, and you could fit a Tele neck on a 3-inch wide, but you can't fit a Strat. 4 inches is really good for a Strat style, and it really works for my design also. So those of you that have the task by episode sheet, if you look on there, here's what it says. Neck, practice neck out of poplar or other inexpensive wood. Okay, then once you get done that, start your real neck. Okay, I'm not going to show the practice neck today. I'm just going to go right into it. But if this is your first build, or maybe you're just not super confident in your abilities, the best thing is to do a practice neck out of some softer, easier to work with material. Poplar is a good choice, or whatever you have in your local area that's inexpensive and easy to work with. And then as you do certain tasks, you parallel it with your real neck. So once you successfully route your truss rod channel, then go to your real neck and do it. Okay, so I just want to explain what you see in these notes and how it kind of differs. In addition to that, you will see to flatten, to square, to trace your template, to route your channels, drill your alignment holes, and then install the carbon fiber or whatever neck reinforcement you're using, if at all. The neck reinforcement is an option, but it's one that I feel like is worth the extra time and effort. All right, so this workbench is not guaranteed to be dead flat. But as you can see, I've got a pretty substantial rock out of this piece of wood. There's a little twist in this piece of curly maple. There's also an ever so slight bow fore and aft. So we're going to want to get that out. And the tool to do that with is a jointer. Now, I had a question from someone who emailed me requesting the docs. Do I have an episode or a video that discusses what tools you need for guitar making? And I'm telling you what, this is a huge topic. I don't even think I could cover it in one episode. I don't even know if I could cover it in 3 episodes. It starts somewhere, and to me, when you're talking about general woodworking, the starting point is a table saw, a jointer, and a planer. Soon after that becomes a bandsaw. Okay, so these are kind of, I don't know, the Fantastic Four, is that trademarked? Of any woodworking, the 4 tools that you need. Now there's other tools that you're going to add. You're going to add maybe a chop saw. You're going to add a router table. You're going to add different sanding, a spindle sander, or maybe an edge sander, or maybe a drum sander. There's a whole bunch of different things that you could certainly add to make your life easier. Most of those things have other ways to do it, but the right tool for the job makes the job generally turn out better and is more efficient for sure. With a jointer, a 4-inch is more than enough to do a 4-inch neck blank. So you can get away with that. The wider the jointer, generally the longer the bed, the more stability you're going to have for longer pieces of wood. You may or may not need that capability. So, but this is a place that we've got to start with those basic tools. Now, eventually, as we get into guitar making, there's going to be a lot of different hand tools you're going to maybe use or need. You know, maybe some hand planes, maybe some chisels, and maybe some of those hand tools come even before the power tools. And I will tell you that some of the tools I have now, I've had for 30 or 40 years. So it's really a long-term endeavor if you have that many years, okay, in order to collect the tools that you need to do the best job that you can. First thing I'm going to do is I'm going to pick a side. That's right, you're going to pick sides. It's okay to do that. All right, I have got an ever so slight bow this direction. All right, so when I take this to the jointer, it'll be easier to flatten this side than it will be this side that's rocking back and forth, because at least on this side, the two ends are going to be on the table, and you'll start taking passes until you remove those down until it's taking everything off. So I'm going to choose to do this side. And I'm going to take just a pencil, and I'm just going to draw a squiggly line from edge to edge all the way down this. And what this will tell me is when all of these pencil lines are completely gone, this board is perfectly flat. See that? There's the twist. Okay, now we've got this one side perfectly flat. In fact, we can put it right on here, and you will see this is a cast iron machine bed, and there is no bounce, no play in that whatsoever. The other side still has the twist. All right, so this is the point that we want to be. Now, after I ran this flat, I took one edge, and that would be this edge. This one is still bad. And I ran that to get that edge perfectly square. So this would be like two square. Square here, square there. And the next thing that we are going to do is we're going to want to get this flat, but what I'm going to do before then is I'm going to run this across the table saw. Right now I'm about 4 1/8 inches. And I can leave it that way, but in the end, I want both of these sides parallel. Since I'm working off of a center line, I may be using either one of these sides for my router table. So I want to have this perfectly square. The only way to get it perfectly square is not running this side across the jointer, because then it may be tapered. So I've got to run it across the table saw and take off at least a blade's width all the way across there, then I can clean it up with one pass on the jointer. All right, we've gone to the jointer and the table saw. We've got this side perfectly flat, and we've got these two edges parallel to each other. I'm at right under 4 inches wide, but I do have them totally smooth and parallel on either side. Now we've got to take this down to the desired thickness. Now, generally speaking, the desired thickness is 3/4 of an inch. And I say general, and I cover this every time I teach this class, but it depends. That's my favorite answer. So you ask me a question, I say, well, it depends. And it's not just something to get out of answering a question, because there are factors that affect each other, and this is the first one that we come into. What it depends upon is how thick is or will be your fretboard. Okay, so the common thickness is 1/4 inch end thickness, but some people prefer more fretboard, a thicker fretboard. So because of that, and because of the fact that there's going to be sanding involved in these processes that's going to take a little bit more off, I'm going to try to leave an extra 20 thousandths, 25 thousandths, maybe something like that. So in this particular case, I'm going to take it down to 0.78, 775, somewhere around there is going to be my ultimate thickness. And that's the reason why. So you really have to pay attention. Just don't go and automatically go down to 3/4 of an inch, because there's variables you have to consider. So the tool for this is a planer. If you don't have a planer and you're going to hand plane it, I'm telling you, it's a challenge. You can do it, and especially if you're doing a lot of handwork, you can do it, but it is a challenge to get this perfectly flat and perfectly parallel to the already flattened side. That is what a planer does. Because this is curly maple, I do have some chipping going on here. And I'll give you a close-up of the jointing process here, and we should be able to see, there we go, there's a chip right there. And as we work our way down, you'll probably see a little bit more chips down this end. Not too bad down there, but there's a little bit in that area. Chipping is hard to escape when you're working with figured wood. That's the downside to the ultimate beauty that we're going to have out of figured wood. So how do we counteract that? We counteract that by a little bit more sanding. In a perfect world, we wouldn't have to. With perfectly sharp blades, maybe we don't have to. But I plan for it. And therefore, I'm going to take this down and leave myself another maybe 20 to 30 thousandths. In that case, I'm looking at 0.80 to go down to on the planer. And that leaves me about 25 thousandths that I can then take it down with a sanding operation, a drum sanding, a wide surface belt sander. All right, the whole goal is to try to minimize tear out, especially in this highly figured wood. So if you notice, I ran it through straight. I got a bunch of chip out. I turned it 180 degrees around, and I ran it that way to see how much chip out I got. It was less, so I kept it oriented that direction, and then I tried to put it in at an angle. Okay, my planer is 20 inches wide, so I can use a pretty significant angle, and that allows a little bit more shearing to happen around this figure, and that reduces the tear out even more. So there's techniques that you can use in each one of these tools to get it exactly the best that you can. Now I stopped at 820 thousandths, 0.820, because another half a revolution would have taken off 40 thousandths, so that would have been too much. So I decided I'm just going to take the extra 20 thousandths plus what I had planned to off on the sanding, the surface sander. I don't know if you can see that, 0.7805. Pretty good. We want to go ahead and mark the center line. In fact, we are going to do a lot of marking, and I'm going to try to show you some close-ups of what we're doing, especially if you're doing one build at a time. I think it's good to go through this process. It really gives you just situational awareness on what everything is going to happen. If you're doing more production and you do one setup and then you run multiple necks, then you probably don't need to repeat this on every single one. But what we're going to do first is establish a center line. Now, like I said, depending upon your headstock design and the width of your board, the center line of your guitar neck may or may not be in the center line of the board. You have to figure that out for yourself. For me, it is. So I'm going to set this up to about 2 inches, and I'm going to make a mark and then flip it around and make another mark. If I'm perfectly centered, it will be the same place. If you're not perfectly centering it, then it doesn't matter. You just mark it from one side, and that side becomes your reference side. But I'm just double checking, and it looks both center on both sides. Now we can take a straight edge and we can connect the dots, and we have got then our center line for the neck established. So I've got extra room fore and aft. If I had a grain that was better one area or the other, I'll move it. But in this particular case, it's really not much different. So I will just center this template over my line, and I will trace it out. Now, before I move the template, I want to go ahead and mark key features, like I'd like to know where my nut is going to be. We've got the hardened steel drilling bushings here, and I could drill those out right now. But I'm going to encourage you to hold off on that until we get all the routing done. And the reason is, if our center line drifts ever so slightly during the channel routing process, we can adjust this template to accommodate and then drill the alignment holes. And I'm going to center it in between my alignment pins, so it shouldn't affect either one of those. And it's going to be about 1/8 of an inch off. I'll double check this. But this is approximately the line where it's crossing. Okay, CF, carbon fiber, CF, carbon fiber. Now, I normally use the spoke wheel for all my builds, but since I know a lot of you intend to use, and I say that because based upon the number of students that I've gone through, and the majority of them choose the headstock entrance. So in that particular case, I'm going to figure out where this layout is going to be forward and back, and it's about the same position. Here's the key thing. The key thing on your fore-aft position is that after the nut, you're going to have about 1/8 to 1/4 inch of wood, and then it's going to kind of swoop down and off. You want this to be buried underneath of there. So therefore, I'm not going to come out any more than about 1/8 of an inch to the end of that, so that it's kind of buried in the wood ever so slightly. So I'm going to set it up right about there, which looks to be approximately 1/8 of an inch, and I'm going to mark the channel on the other side, which is really close, probably within 1/8 of an inch of the other side of it. So therefore, my routing has got to go from the forward position of this block, which will be right about here, all the way to the end, which is already marked there. So I'm going to label that as TR. What's that stand for? Truss rod. All right, so I've got my truss rod, I got my carbon fiber, my starting and stopping points. I'm laying this out. Everything is looking good. At this point, I would be ready to go to the router table and begin routing these out. But I'm going to have to do a little something different first. And the reason is because I'm using a table router. This is going to be upside down. I need to continue these lines and these labels to the other side where I can see them. And I'll do the same for this side. I'll carry my labels, carbon fiber and truss rod. We want to make sure we know what dimensions that we have here. So I know that these are the hot rod truss rods from StuMac. They're a little weird shaped. They're 7/32. So really the bit that you're going to have to use is a 7/32 by, okay, how deep are we going to go? Let's call it 0.45. So 0.45, and then I'm going to give myself maybe an extra 10 to 15 thousandths. 0.45, let's go 0.446. We'll just go 0.46 inches deep. I do not want these blocks to stick above the surface. If anything, I'd rather have them recessed by 10 or even 20 thousandths. Let's bump that up to 7. Let's go 20 thousandths. 0.470. these carbon fiber rods that I'll be using. 0.247 by 0.2495. So really, they're a 1/4 inch by 1/4 inch, but this way is more perfectly a 1/4 inch. So I'm going to do it that way, and I'm going to go a 1/4 inch bit by 257. So that's another 10 thousandths extra to make sure that these go below the surface, and those will be glued in with epoxy. So those are the dimensions that we're going to need. I've got parallel guides here. This was a jig that I developed a few years back, and look back in my Tools and Jigs series, I believe, and you'll find this. It's made out of 80/20 aluminum, and it's pretty cool. The parallel edges helps keep the stock perfectly straight. Not really necessary, but at the time I thought it would be a help for my students. And I have taken it to class a few times, and they seem to like it. But again, you know, if you got a standard fence system on your router table, that'd be more than sufficient as long as you're taking light passes. And when I say light passes, typically I want to do no deeper than the diameter of the bit. Preferably about half the depth of the diameter of bit. So this is 7/32. It's a little bit under a 1/4 inch. So typically I'm shooting for about 1/8 of an inch passes. That allows me to creep up on my depth that I need, and also keep the bite small enough where the piece of wood, if you're using a single-sided fence system, doesn't try to pull away from the fence. So if you have extra material on your design and you leave that extra material at the heel side of your neck blank, you can run some test cuts in the very end. Even though this truss rod is going to start up here, I can run the test cuts. Now, I didn't do that. I shifted it more to the back. So I cut off the extra from the front. It's a little bit too small just to kind of run by itself. So I'm going to use it as a backer piece for this, and I'm going to push it in a little bit and then back out and double check that that bit is exactly center line on this block of wood, or exactly where I want it to be. So we're going to do that real quick. And once that's established, we'll start making our passes for real. Okay, after a couple test cuts, I'm with 0.1 millimeters. That's about 2 to 3 thousandths of perfectly dead on my line, which is dead center in this piece of wood. So I'm pretty content with that. One last bit of safety. Even though that bit is only sticking out 1/8 of an inch, I will never have my hand pressing down and pushing this through. It is possible, if that bit was not tightened down to proper torque setting, that that bit could pull its way into the wood and actually come through the wood. Now, that's obviously not desirable for a good neck, but more importantly, if you damage the piece of wood, you're in an early stage, just get a new piece of wood and start over again. If you damage your finger or cut off a finger, then, you know, that's certainly more valuable. So always be careful, always use push blocks when you are over top of a bit. All right, the trick of this is start somewhere to the right of your stop point, get it down, plunge down, and then back it up to that, and then continue forward to the other line. All right, first pass from one line to the next line. Now I'm going to go and do that more times to get it all the way down to the desired depth, and that will be done. 0.47, 1-0, extra thousandths there. Okay, I got the parallel fence system realigned, offset, and you can see here's my original truss rod slot. I would recommend that whatever scrap piece you use for your test cuts, just keep it and keep going to the full depth, and that way you can use it. So I offset this to one side to get about 1/8 of an inch separation. You don't want to get any further spread out than 1/4 inch, but I like to keep it a little bit tighter just so that once the neck contour is cut, that I know I'm going to have more than enough. If I get too far out, it could be getting awful close depending upon what shape of neck contour that you do. So I like to keep them a little close, no closer than 1/8 of an inch for the strength of that piece of wood there, and probably no further away than 1/4 inch. All right, we're getting close to wrapping up this episode. Don't leave too soon. This could be the most important thing of all. Probably not. But we do have a really good fit of the 7/32 truss rod. I don't think I mentioned it in the video, but we had to swap to a 1/4 inch router bit when we were doing these channels, and we've got those to a depth that again is 10 thousandths or so below the surface. That'll be fine. This guy won't sit fully below the surface because we're going to have to drill out the hole in the headstock for that Allen wrench adjustment. So that's what we're doing on this neck here. The other neck, I'm going to do the spoke wheel like I normally do for my guitars. But this is what we're going to do next. The last step we've got today is to glue these bad boys in. I've already assured the fit, and it's a good fit. They're not overly tight. And they're not loose either. So can't complain about that. I mix up a little bit of epoxy. This is not 5-minute epoxy. This is like 1 hour and 37-minute epoxy, which is fine. It gives me time to work. And so I mix up just a little bit of that. And I like to spread it in there real thin with a brush. So one of these little glue brushes are awesome, except I don't like 1-inch bristles. I'm more of a 3/8 inch bristle kind of guy. We want to have a little bit of acetone on a rag available. That is what's going to break down this epoxy. And any that gets on the surface, I want to wipe off after I press these into place, just so there's nothing that's impeding the glue that I use to glue the fretboard. And since we're using a very traditional Indian rosewood fretboard, I'm pretty confident in the ability to use standard Titebond, original Titebond glue, and that will hold just fine. The other fretboard that I'm using on that roasted maple, if you remember I guess that was the introductory episode where I pointed that out. That we probably will, that's a little bit more oily. We probably will use epoxy to secure that in place. In which case, it wouldn't matter if I clean this up. I could just wipe it down without acetone and it would be fine because epoxy will cure to epoxy. No matter how little of this epoxy I mix up, I always seem to have too much. If anybody's nearby, you want to come over and use the rest of this epoxy in the next 1 hour and 37 minutes, you're welcome to come over. Of course, it'll take me like 8 hours to post this video, so never mind. To me, here's the key. If I can press it down with finger pressure so that epoxy kind of begins to squeeze out ever so slightly, and I can feel with my fingernail that it is definitely below the surface, then I do not need any clamping action. I'm just going to wipe this down with a rag and a slight bit of acetone, and I'm just going to let it sit. And in 1 hour and 33 minutes now, it will be ready to go. And then we will be ready for the next episode part 3 of our School Strat Build series coming right at you. So until next episode, remember, no matter what you do, start with excellence.